Hey, I'm Brian. I make animatronics, and I'm going to show you the process I went through to build the 3D printed mechanics of my animatronic Donald Trump puppet. Thing I'm most concerned about is the big old head moving around on a skinny little neck. The laws of physics dictate that you gotta have leverage. That means a big neck. I don't want a big neck, I want a big head, I want a little neck. So I'm gonna have to discover where that sweet spot is. At the beginning, I want to put things together as quickly as possible. My philosophy when building anything is to get it wrong so I can do it right. That is why I love 3D printing, because I don't have to waste time making stuff. I just design stuff, figure it out, and then my robot slave, aka the 3D printer, makes the parts for me, and then I assemble it and then see where I landed in terms of doing it well. I usually get pretty close to doing it well. We'll see how it goes. All right, yeah, we got most of the components together. Most of the system is in there at least, and so we can see how the weight goes. There are issues, and there are always issues. In this case, it's because we went with plastic. I've been building these things for years, machining them out of aluminum, and you get used to doing things a certain way. Plastic is not aluminum. It's flexy and brittle and breakable, and it needs to be accounted for. It works pretty well. The main issue is the amount of wobble. The servo brackets are flexing like crazy. The base flexes. Everything flexes, and so the head just woggles. The servos are trying to get things, the feedback is going wonky, so it echoes. But it's just so not steady. Need to beef everything below the neck up. Try to get rid of this wiggle woggle. Otherwise, it's pretty cool. You gotta rotate and a head movement. I gotta redo the linkages in the jaw, but the jaw works. But this is with all the weight on this gimbal being supported directly by these servos, the linkages. And it's just too flexy and wobbly and boingy and floppy and everything else. Kind of cool, but not what we're going for. We want smooth movements. Smooth. Oh yeah? Tell me more. Ooh, baby. You smooth. Not boing. All right, here is the plan. Everything is going to be bigger and stronger and more better. Redesigned and reprinted brackets for servos. The base. I'm going to shorten these control rods, and I'm going to stabilize this center shaft. I mean, it's steel. It's got a little steel collar on there. I thought it would be good and strong. It is strong. Everything around it is weak and flexible and plastic. So, going to rebuild. Going to be great. All right, let's take a look at how it performs now that we've improved a few things. Now we had lots of flexation going on in these areas where these servos are mounted. The weight of the head slings around and has everything just flexing and going along with it. It is much more stable. Some of the things I changed. I beefed up these brackets considerably. This is what it was before. This is something I might have machined out of aluminum once upon a time, before they invented robot slavery. And now this is the big beefy plastic thing. More material, less flexy. It's dandy. Same thing over here, 2 servos. I kept the base solid, so there's no flexing there. I added lots of little holes for things to be added on later on. And the other thing is I put a cross piece across both servos, keeps them from wiggling in and out, and it also serves to grab that steel shaft that goes from the base all the way up to the neck universal joint. So there isn't any ability to do any wiggling that way. And this has the added thing of I put little the ability to put some shoulders on there later on. Right there. So all together a nice improvement. It still has its range of movement. I mean, any woggliness is now, ooh, boy, that thing wants. I mean, you're not going to do that anyway, right? Right. Not what you want. You want nice, smooth movements. As long as the movements are smooth, there isn't any weird wiggle. The servos now have the ability to stabilize without oscillating back and forth, trying to find that sweet spot. I actually see the servo moving just a little bit because I only have 2 screws in there. I'll put the 3rd and 4th screw in. Some of the things I also added were these threaded inserts. These are, you install these with heat, soldering iron, press them in. That has the benefit of being able to take screws out and put them back in and not munging up the threads. The thing about animatronics or any mechanism is you put it together and you take it apart, and then you put it back together and then you take it apart, and then you make some changes, and then you look at it and then you realize you gotta redo it. A friend of mine says the job isn't finished until you've taken it apart and put it back together at least 8 times. Yeah, it sounds like an exaggeration, but it's pretty damned accurate. I think I'm on 3 times, so I've got 5 more times before this is finished.